Hello guys, it's Ahmet here. I am graduated student from Boğaziçi University and I am doing my master thesis at the same university. My major was teaching of mathematics. I love mathematics and I decided to shoot those videos to solve the problems. I am going to solve the problems from Gilbert Strang's linear algebra book. The problems taking place at the end of each chapter and each section. This is the book, the original book. Since I live in Turkey, this is the copy of the book that was produced for other states other than United States. I'm going to solve the problems in that paper and add the problems as a picture at the end of the videos or at the beginning of the videos. Why I'm doing this? Because I love mathematics and I love helping students from all over the world. This is a notebook on which I'm gonna solve the problems. I put a book holder in at the top of the notebook because there is a logo of a university and I don't want to mention that logo of university because of the copyright issues. So let's start with and this is a view. This is Hagia Sophia, this is Blue Mosque. You may be familiar with those mosques. They are located in the very famous one of the very famous cities of the world, Istanbul. For the first question of the problem set 1.2, it says solve to find a combination of the columns that equals B. So we should these three equations are given, and we should find the combination of the columns that equals B. So all we have to do is to find those W, V, and U in terms of B's. So W is already W or omega, however you call it, is not important. W is already equal to B3. This is given in the equation. Then we find what is V. V is equal to B2 minus W. W is equal to B3. So B2 minus B3 is V. And U is equal to B1 minus B2 plus B3 and plus B3. So B3s are cancelled out and B1 minus B1 plus B2 is the answer. So these are the columns in terms of B that gives the B column, and these are the U, V, and W's. In the second question, it says sketch these three lines and decide if the equations are solvable. These are three equations given in the question. I sketched the graph. This is y-axis, this is x-axis, and this is the line of x minus y is equal to 2, and this is the graph. This is the line of x plus 2y is equal to 2, and they intersect at one point. But there is also other line. This is y is equal to 1. So from the graph interpretation, since there is no common intersection point of those three lines, because this line intersect, this line intersect y is equal to 1 is that point, and this intersect this line at this point, this intersect with this line at this point. So since no common intersection points by three lines are observed, there is no solution for those lines. This comes from the interpretation of just by observing the graph. When we do the calculation, when we do the algebra, we got we got y is equal to 1, so we put y here. So x is equal to 3 and x is equal to 0. So this must be hold, but x cannot be both 3 and 0 at the same time. So this is no solution. And in the further of the question, what happens if all right hand sides are 0? what happens if all right hand sides are 0? Then we got x is 0, y is 0. So this is the origin point. So this is a solution. Then we got a solution. And it says, is there any non-zero choice of right hand sides that allows three lines to intersect at the same point? So for example, I assign y is equal to 2, x minus y is equal 1, and x plus 2y is equal to 7. That gives me the point 3 and 2. So yes, there is any non-zero choice of right hand sides. In question 3, for those equations, draw the row picture. It says in the question two intersecting lines. So the row picture must look like this. These are the x's, and this is the line of this equation, and this is the line of this equation. This is the intersection point of those two lines. So I mean, I guess this is the row picture, because in the question, in the parentheses, it states that two intersecting lines. So these are intersecting lines. I guess this is the row picture. And the column picture, combination of two columns equals to the column vector 4 and 4 on the right side. So I guess this is the column picture 1 to x. This is column picture 1 to x plus 1 minus 2 y is equal to 4 and 4. This is the column picture. In question 4, it says find 2 points on the line of intersection of the 3 planes. These are 3 planes, and we are asked to find the 2 points on those lines. So it's already written, it's already decided t is equal 0, z is equal 0, x plus y is equal 1. So this gives me a line, right? This is 0, this is 0. These are points on 4-dimensional space. But this indicates line. So I can choose any points on that line. For example, 1 plus 0 is equals 1. This summation is hold for this, and this subtraction is hold for this equation as well. So I can find as many other points as well, those a and b's. 5 is recommended question by Gilbert, I think. It says describe the intersection of the 3 planes. These are 3 planes. And it says, is it a line, is it a point, or an empty set? So when we solve this equation, w plus u is equal to 2, and then we got z is equal to 2. And when we got z is equal to 2, and those summation are equal to, u and w is equal to 2, then v is equal to 2. So we have w plus u is equal to 2, z is equal to 2, v is equal to 2. So as in the above example, in the 4th question, we discussed this. This is a point, but this is a line. So this indicates a line for me. So in the question, it says, what is the intersection if the 4th plane u is equal -1 is included? If u is equal to -1 is included, then w is 3. It defines a point, not a line anymore, because I got this line and I put u here, and then w equal to 3. So it defines a point. And then it says find the 4th equation that leaves us with no solution. So z is equal to 2, v is equal to 2. If I add z plus v equal 6, that contradicts those points. So I got no solution. You can add any line or any equation you wish to add that contradicts any kind of those.